Hello, welcome again. We are solving mechanical engineering paper 1 of year 2025 of civil services mains exam. Question number 3A2 is a punching press executes 10 holes per minute in a 25 mm thick plate. The diameter of each hole is 20 mm. The punch has a stroke of 60 mm and the punch moves with uniform velocity throughout. A flywheel is attached to the press and the mean speed of the flywheel is 25 meter per second. A punching requires 10 Newton meter of energy per mm square of the sheared area. Find the power needed to operate the punching press. Further, determine the mass of the flywheel required if the total fluctuation of speed is restricted to 5% of the mean speed. So here it is given that diameter of hole is 20 mm, thickness of hole is 25 mm, mean speed is 25 meter per second, stroke is 60 mm and coefficient of fluctuation of speed is 0.01. So here the thickness 25 mm, diameter 20 mm, stroke 60 mm and mean speed 25 meter per second, coefficient of fluctuation speed is 5%. Okay, so or we can say coefficient of fluctuation of speed is 0.05. So as it is required to carry out 10 holes in 1 minute, so time required to carry out one hole is 6 seconds. Okay, so energy required per hole or energy supplied by motor in 6 seconds, because one hole is being carried out in 6 seconds, so whole of energy actually will be supplied by motor, or that is energy required also by one hole. So energy required per hole is your area of hole into energy required per mm square. So energy required per mm square is 10 Newton meter per mm square, and area is pi dt, shared area is pi dt, pi into d into t. D is 20, t is 25. So from this we get the energy required for one hole is 15707.96 Newton meter, and that energy is required in 6 seconds, because one hole is being carried out in 6 seconds. So energy supplied by the motor in 1 second is divided by 6, that is 2617.99 Newton meter, or we can say it is power of the motor is 2.61799 kilowatt. So now the stroke length is given as 60 mm. So during punching one hole, the punch travels a distance 120 mm downward plus upward, that is 60 plus 6, that is 1.6, and that is that distance will travel in 6 seconds. Okay, because 10 holes are to be punched in 1 minute. So and the thickness of the hole is 25 mm. So for actual punching the time is, because for 120 mm the time is 6 seconds, for 25 mm it will be 6 by 120, that is 1.25 seconds. So actual punching takes only 1.25 seconds. The punch is coming down, doing hole, and then going back. Okay, so actual punching operation will be only of 25 mm length, and that will be carried out in 1.25 seconds, because for traveling 120 mm the time required is 6, for traveling 25 mm the time required is 1.25 seconds. Okay, we can make this calculation. Now during that time, during actual punching, the energy is supplied by the motor also, and the motor is supplying 2.61799 kilonewton meter per second. In 1.25 second it will supply this amount of energy, that is 3.2724 kilonewton meter, or we can say it is 3272.4 Newton meter. So that is energy supplied by the motor in 1.25 seconds. Okay. So now this is the energy supplied by the motor during actual punching, and rest of the energy will be supplied by the flywheel. Total energy required is that we have calculated to carry out one only 15707, but the energy supplied by motor during actual punching is 3272. So rest of energy will be supplied by the flywheel, which is stored in rest of the cycle except this 1.25 seconds. So that is also the fluctuation of energy of flywheel, that is represented by E small e. So it will be 15707 0.96 minus 3272.4. It will come out as 12435.56 Newton. And we know that the fluctuation of energy is 2 into K into E. K is computer fluctuation of speed, and E is mean energy. And mean energy can be found by half mv square. So V is given, that is 25 meter per second. So from this we get M as 397.933.